One of the most versatile aircraft in the U.S. Air Force inventory, the F-16 Fighting Falcon has been the mainstay of the Air Force aerial combat fleet. With over 1,000 F-16s in service, the platform has been adapted to complete a number of missions, including air-to-air fighting, ground attack and electronic warfare. In an air combat role, the F-16's maneuverability and combat radius, distance it can fly to enter air combat, stay, fight and return, exceed that of all potential threat fighter aircraft. It can locate targets in all weather conditions and detect low-flying aircraft and radar ground clutter. In an air-to-surface role, the F-16 Fighting Falcon can fly more than 500 miles, deliver its weapons with superior accuracy, defend itself against enemy aircraft, and return to its starting point. An all-weather capability allows it to accurately deliver ordnance during non-visual bombing conditions. In designing the F-16, advanced aerospace science and proven reliable systems from other aircraft such as the F-15 and F-111 were selected. These were combined to simplify the airplane and reduce its size, purchase price, maintenance costs and weight. The light weight of the fuselage is achieved without reducing its strength. With a full load of internal fuel, the F-16 can withstand up to 9 Gs, 9 times the force of gravity, which exceeds the capability of other current fighter aircraft. The cockpit and its bubble canopy give the pilot unobstructed forward and upward vision, and greatly improved vision over the side and to the rear. The seat back angle was expanded from the usual 13 degrees to 30 degrees, increasing pilot comfort and gravity force tolerance. The pilot has excellent flight control of the F-16 through its fly-by-wire system. Electrical wires relay commands, replacing the usual cables and linkage controls. For easy and accurate control of the aircraft during high G-force combat maneuvers, a side stick controller is used instead of the conventional center-mounted stick. Hand pressure on the side stick controller sends electrical signals to actuators of flight control surfaces such as ailerons and rudder. Avionics systems include a highly accurate enhanced global positioning and inertial navigation systems, or EGI, in which computers provide steering information to the pilot. The plane has UHF and VHF radios plus an instrument landing system. It also has a warning system and modular countermeasure pods to be used against airborne or surface electronic threats. The fuselage has space for additional avionics systems. The F-16A, a single-seat model, first flew in December 1976. The first operational F-16A was delivered in January 1979 to the 388th Tactical Fighter Wing at Hill Air Force Base, Utah. The F-16B, a two-seat model, has tandem cockpits that are about the same size as the one in the A model. Its bubble canopy extends to cover the second cockpit. To make room for the second cockpit, the forward fuselage fuel tank and avionics growth space were reduced. During training, the forward cockpit is used by a student pilot with an instructor pilot in the rear cockpit. All F-16s delivered since November 1981 have built-in structural and wiring provisions and systems architecture that permit expansion of the multi-role flexibility to perform precision strike, night attack and beyond visual range interception missions. This improvement program led to the F-16C and F-16D aircraft, which are the single and two-place counterparts to the F-16A divided by B, and incorporate the latest cockpit control and display technology. All active units and many Air National Guard and Air Force Reserve units have converted to the F-16C divided by D. The F-16 Fighting Falcon was built under an unusual agreement creating a consortium between the United States and 4 NATO countries, Belgium, Denmark, the Netherlands, and Norway. These countries jointly produced with the United States an initial 348 F-16s for their air forces. Final airframe assembly lines were located in Belgium and the Netherlands. The consortium's F-16s are assembled from components manufactured in all 5 countries. Belgium also provides final assembly of the F-100 engine used in the European F-16s. Recently, Portugal joined the consortium. The long-term benefits of this program will be technology transfer among the nations producing the F-16, and a common-use aircraft for NATO nations. This program increases the supply and availability of repair parts in Europe and improves the F-16's combat readiness. Since September 11, 2001, the F-16 Fighting Falcon has been a major component of the combat forces committed to the global war on terrorism, flying thousands of sorties in support of Operations Noble Eagle, Homeland Defense, Enduring Freedom in Afghanistan and Iraqi Freedom.